Hello everyone, I welcome you all for the second PUC practical session. In this session, we will be learning the experiment ammeter. Okay? So the aim of this experiment is to convert the given galvanometer into an ammeter of the required range of 0 to 30 milliampere and verify the same. So in this experiment, our aim is to convert a given galvanometer into an ammeter of required range. You know that the galvanometer is a device which measures a very small amount of currents in a circuit, like in the range of microampere. But in general, we will be dealing with the currents in the range of milliampere. So using a galvanometer, how can we measure the current of the range in milliamperes? So that is what the experiment is. Okay? Well, let us look at the apparatus required for this experiment. A pointer galvanometer, a battery, ammeter, resistor, key and rheostat. So these are the apparatus required for this experiment. And what is the principle of this experiment? We need to understand the principle of the experiment. Let us understand it. Galvanometer can be converted into an ammeter by connecting a suitable low resistance in parallel with it, so that a very small current flows through the galvanometer. Let us understand the principle of the experiment by drawing a circuit. Let us understand it. Let us say that this is a galvanometer and you know that the galvanometer is having some finite value of resistance which is around 50 ohm. Okay, fine. Let us connect a small resistor in parallel with the galvanometer. Okay, we are connecting a small value of resistance in parallel with the galvanometer, and this should be called as a shunt resistance, correct? A shunt resistor is a resistor which is having a very smaller value of resistance and is connected in parallel with the galvanometer. Now, suppose if I is the current which is entering into this junction, and you know that at this junction the current is going to divide and the current flowing through the galvanometer is say Ig, and the current through the shunt resistance is I minus of Ig. So this has been written using Kirchhoff rules. Okay. Now, if Ig is the current required to produce full scale deflection. So what is this Ig is? Ig is nothing but a current required to produce the full scale deflection in the galvanometer. You know that when current is passing through the galvanometer, it shows the deflection. Say this Ig is the current which is required to produce the full division of deflection in the galvanometer. Since this shunt resistance is having a very smaller value of resistance compared to the galvanometer, maximum amount of current will flow through the shunt resistance and a very small amount of current will flow through the galvanometer. Now let us write what is the value of this shunt resistance in order to get the full scale deflection in the galvanometer. As these two components are connected in parallel, the potential difference across the galvanometer and the shunt resistance will be same. So let us write that potential difference across S is equal to potential difference across galvanometer. The current is I minus Ig and the resistor is S, therefore this is I minus Ig into the resistance S. Okay, and the potential difference across the galvanometer is this. If G is the galvanometer resistance, then Ig into G is the potential difference across it. So Ig into G. So we get the value of S, so that we get a value of S as Ig into G divided by I minus of Ig. Okay. Suppose if I is the current, which is if I is the current that we need to measure here. So we get an expression for S as Ig into G divided by I minus Ig. So what is this I is? I is the current or the maximum current that we need to measure using a galvanometer, and this Ig is nothing but a current required to produce the full scale deflection. We are going to measure a maximum current of 30 milliampere, therefore the value of current is 30 milliampere. We need to find what must be the value of shunt resistance for a given galvanometer. Now let us draw the circuit diagram that we are using in this experiment. So this is the circuit diagram used in this experiment. So we have the components, battery, this is a plug key, rheostat. We'll be using a milliammeter here, and this is a galvanometer, and this is nothing but a shunt resistance which is connected in parallel with a galvanometer. The shunt resistance is nothing but a wire which is having certain length. So we need to find the resistance of that shunt using this experiment. Okay. Now let us look at the apparatus required for this experiment. The apparatus in this experiment are the galvanometer. This is a battery. This one is a milliammeter, a rheostat, a plug key, and the shunt resistance is nothing but a wire. Okay. So this wire is used as a shunt resistance, which is nothing but a nichrome wire. Now let us connect the circuit. So as in the circuit diagram, from the positive terminal of the battery to the positive end of the milliammeter, let us connect this from the positive end of the battery to the positive end of the milliammeter. Next, from the negative terminal of the milliammeter to the galvanometer, from the negative end to one of the end of the galvanometer. Next, from the galvanometer to the upper end of the rheostat, from the galvanometer to the upper end of the rheostat. The lower end of the rheostat is connected to the plug key. From the plug key to the negative end of the battery. Yes. So we are left with connecting this shunt resistance now. So how do you connect the shunt resistance? I told you that this wire is nothing but a shunt resistor. So we have to connect this shunt resistor in parallel with the galvanometer. So I will connect one of the end of this wire to the one end of the galvanometer. So I am connecting this. The other end is connected from the upper end of the rheostat. So we are connecting the shunt resistance, the other end of the shunt resistance to here. Okay. So we are connecting from here. We are having a crocodile clip here. So we will be connecting from this upper end of the rheostat to the S, that is shunt resistance. So I am connecting this. This completes the circuit. So in this experiment, we need to find what must be the length of this wire so that the shunt resistance is connected with the galvanometer, then it will be converted into an ammeter. So we need to connect this wire such that the length must be equal to the length of the shunt resistor. First we need to calculate the value of shunt resistance for the required range of current. So first let us do that. So in this experiment we are converting a given galvanometer into an ammeter by connecting a shunt resistance in parallel with the galvanometer. So in the observations, first the resistance of the given galvanometer which is equal to 50 ohm. Next, the figure of merit of the given galvanometer is written as K is equal to 20 into 10 power minus 6 ampere per division. So these values are given. Next, number of divisions on either side of 0 of the galvanometer scale, N is equal to 30 divisions. How do you find the current required for producing the full scale deflection? See, the K is nothing but a figure of merit, which is the current needed to produce a unit deflection. There are totally 30 divisions. So for producing this 30 division of deflection, you just multiply K with N. So N into K. So if I multiply N and K, N is 30 and this is 20 and this is 20 into 10 power minus 6 ampere per divisions. So if I multiply these two, we will get 600 into 10 power minus 6 ampere. In this experiment, we are measuring a maximum current of 30 milliampere. So let's find out what must be the value of shunt resistance. So we have a formula, S is equal to Ig into G divided by I minus of Ig, and if I substitute the value of Ig is equal to 600 into 10 power minus 6, this into galvanometer resistance is known, which is equal to 50 ohm, divided by I minus of Ig. I is nothing but 30 milliampere. Let us write this, 30 into 10 power minus 3 minus of Ig is again 600 into 10 to the power of minus 6. Let us do this. For the value of shunt resistance S will be equal to 1.02 ohm. That is, we must connect 1.02 ohm of resistance in parallel with the galvanometer to measure a current of 30 milliampere. I told you that in this experiment, as a shunt resistance, we are using a wire. So the resistance of that wire depends on the length. So up to what length we must connect that wire. So that has to be known. So to find the length, we have a formula. I know the value of shunt resistance as 1.02 ohm. Value of pi is known. R is nothing but the radius of the wire, which is given. So 0.15 millimeters, and rho is the resistivity of the wire. So we are using a Nichrome wire here. So the resistivity of the Nichrome wire at room temperature is 1.1 into 10 power minus 6. So if I substitute these values, what is the value of length we will get? Let us find out. And if you do that calculation, what is the value of length we will get is 0.0655. So if I write this so this is in meters. If I write this in centimeter, in centimeter, this will be 6.55 centimeter. Okay. The length of that Nichrome wire, which has to be connected in parallel with the galvanometer, is 6.55 centimeter. So now we have to verify this experimentally. Let's look at this. Now we are verifying the shunt resistance that is connected in parallel with the galvanometer is having a length of around 6.55 centimeter. First, let us set the battery voltage to be 2 volts. Yes. The maximum current we need to measure here is 30 milliampere. So using a rheostat, first we need to set the current of 30 milliampere in the ammeter. Let's do this. Now the ammeter is showing 30 milliampere. Okay. Now the length that we need to connect is around 6.55 centimeter. So I have already connected one wire here. I have already connected one end of the wire here. So we have to connect to the other end such that the length is equal to 6.55 centimeter. So let us do this. So we have taken a wire from the rheostat, upper end of the rheostat, and I am just plugging the wire. Now we have connected the certain length of the wire, but the galvanometer is not showing the full scale deflection. In the experiment, we need to get the full scale deflection in the galvanometer for this value of shunt resistance. So for this length, we are not getting the full scale deflection. So let me increase the length. Now you can observe the galvanometer is showing the full scale deflection by connecting this portion of this wire. This wire is now acting as a shunt resistor. Okay. So we need to find what is the length of this wire experimentally, but theoretically we know the value of this length should be equal to 6.55 centimeter. Theoretically we know the value of the length we have to connect the wire is 6.55 centimeter, but experimentally let's find out what is the length of this wire. For this portion of length is acting as a shunt resistance. Let us find out this length and we have to verify with the theoretical value. Okay, let's measure this length. So if I measure the length I am getting is around 7 centimeters. Okay, the length is 7 centimeter. So we know that theoretically the value of length should be equal to 6.55 centimeter, but experimentally we are getting the length of 7 centimeter. Let's write that this is L dash is equal to 7 centimeter. Now let's find out the value of S dash. S dash is nothing but the experimental value of shunt we have connected. So we have to find this S dash now. We have a formula for S dash. Let us write that is equal to. So the value of S dash is equal to rho L dash divided by pi r squared. Okay. So let us find this S dash. S dash is nothing but a experimental value of shunt resistance. We are verifying with a theoretical value. Okay. So S dash is equal to rho is 1.1 into 10 to the power of minus 6. L dash The length what we have connected in that wire is found to be 7 centimeter. So we got 7 centimeter as length experimentally. Therefore, this is 7 centimeter. 7 into 10 power minus 2 divided by pi r square. This will be 1.34 into 0.15 into 10 power minus 3 the whole square. So if I do this calculation, what is the value of this S dash? So the value of S dash is found to be 1.08 ohm. Okay. So this S dash is found using the experimental way. But theoretically we know that the value of S is equal to 1.02 ohm for a given wire. So if you compare the theoretical value and the experimental value of shunt, so we are getting almost same. Okay. So now let us write the result of this experiment. So we have 2 points in the result. The theoretical value of shunt resistance, that is by calculations we got the value of shunt resistance as 1.02 ohm. So after doing the experiment, what is the value of shunt resistance we got? That is S dash. The experimental value of shunt resistance S dash is equal to 1.08 ohm. So if you compare the theoretical value and the experimental value, they are almost same. So we have verified that the galvanometer can be converted into an ammeter by connecting a suitable value of shunt resistance in parallel with it. That's all for this session. Thank you.